In this video, we're going to have a look at two examples where we're going to work with circle problems, and it's going to involve working backwards to find an unknown. So it's not just going to be work out the arc length or work out the area. We're going to need to do something a wee bit more involved here. Okay, let's have a look at example 1. The length of the arc is 56 centimetres. Calculate angle X. So we're told that the length of this pink highlighted section here is 56 centimetres. We want to work out this reflex angle. Well, it's mentioning the length of the arc, so I think it would be worthwhile to write down the formula excuse me, for the length of the arc. To work out the arc length, the arc is part of the circumference. So to work out the circumference, we do pi times the diameter. But it's not that, but for a section of a circle to find out the arc, we work with the fraction of it. So it's the angle over 360 multiplied by pi times d. This is going to essentially be a rearranging the subject to the formula question, because we're actually told what the arc length is. We're told that the length of the arc is 56. We know, if I highlight this, we know that this is 56. So 56 there we go. 56 is equal to the angle, which is x, over 360 multiplied by pi multiplied by the diameter. The diameter goes the full way across. So the diameter is going to be 32. Okay, we want to work out x. So in order to work out x, we're going to need to make x the subject of the formula. So if we multiply both sides by 360 first, we're going to get 360 multiplied by 56 is equal to 32 pi x. The goal is to work out x. At the minute, x is being multiplied by 32 pi. So we can divide through it by 32 pi. So 360 multiplied by 56 over 32 pi. Remember, this is going to give us the size of the angle that we're looking for. We're hoping it's a reflex. So 360 divided by 56 over 32 pi. And if we do this to one decimal place, we should find that that angle is 200.5 degrees. So it's a case of like working backwards to find the unknown. Okay, so in this problem we had to work backwards to find out the angle when we were given the arc length. We could be asked to work out the diameter given the arc length. It just depends on what the question is asking. We've got one more example. Let's have a look at the area of the sector. This time we're talking about the area. So we are told that the area of this is 100 centimetres squared. We want to work out the radius. But once again, we're talking about the area. So I think it's a good place to start down by writing down my formula that involves the area. So for the area of a sector, well, the area of a circle is pi r squared. But that's a full circle. If I've got a sector, I need to think about the fraction of the circle. So it's the angle over 360 multiplied by pi r squared. We're told the area of the sector is 100. So see this area sector, I know that that's 100. And that's equal to the angle, 115, over 360 times pi times r squared. Remember, we want to work out what r is. So essentially we're going to make r the subject of the formula. So once again, we're going to multiply both sides by 360. So that is going to give us, wait a second. There we go. We've got 100 multiplied by 360 is equal to 115 pi r squared. We want to get r squared on its own initially, so we'll divide both sides by 115 pi. That's going to be 100 times 360 over 115 pi. That's what r squared is. I want to work out the radius r. So we'll need to take the square root. That's going to be 100 times 360 over 115 pi. Should be able to input that into a calculator. 100 multiplied by 360 over 115 pi. This is telling us the radius. And that's going to be 9.98. So if we did that to one decimal place, that's going to be 10 centimetres to one decimal place. Okay, so sometimes you have to substitute in information and work backwards to figure out what you're looking for. This is generally considered AB content. Okay, hopefully that was helpful. Thank you very much.